afternoon and welcome to Calculus in the PM. I'm your host, Mr. Shidaka, and today's lesson is brought to you by the new taste of Coke, cherry Coke, and dill pickle flavored Coke. Refreshing and unique. Carrying on. Now we're actually getting into applying limits to do something called a derivative. We've already started doing this, but, well, you'll see. We'll get something more formal that works for any equation. Slopes and tangents at the general point, x, comma, f of x. Before, I'd usually say at the point 2, comma, f of 2, right? I'd give you a number. And then I'd say, well, I'll give you this number, a, comma, f of a, right? And you did those. Well, really, how is at the point a, comma, f of a different than saying at the point x, f of x, the general point? It isn't. So finding the derivative is using this general point for any x value. And we know that this idea of doing a limit is where you are really taking the slope between 2 points. But you're getting this distance here, this distance h, so close together it's practically 0, right? So it's almost like dividing by 0. You're getting around the problem of dividing by 0. But you ever look at a curve? If you were, imagine you're walking the surface of this earth. Is it surprising that 5,000 years ago, 3,000 years ago, even 1,000 years ago, some areas of the earth, like when Columbus sailed the ocean blue in 1492 and stuff, people actually, for the most part, thought the world was round. They did. They didn't think it was flat and that he'd fall off the face of the earth. But do you understand why in some areas of the world and stuff like this, people would think the earth is flat? Like, yeah, okay, because you look and you stand, especially in Saskatchewan outside of Regina, it looks flat. It does not look that curved from standing out here. If you go in outer space, it looks curved. Well, this is the whole idea here. Imagine you were an ant on this portion right here of this curve. What shape would you call that right there? Would you call that a line or a curve? You'd probably say it's a pretty straight line, right? If you're only looking at one little portion of this. And this is what I'm saying here. Do you notice that the equation of a tangent line, if you come up with it, 5x plus 2 or whatever, it's going to be the local, just in that little area, that neighborhood, the local linear approximation. That's why I say local in that area, near the point P. So right here, this line that I have going from here to here, and I'm saying it's going to get close, Q is going to be close enough that it's going to be called the tangent line. That's basically the point P. It describes the area very close to P as a linear function. We'll be solving some problems using that fact later on, though. Now, the slope of PQ, using f of x notation and stuff like this, instead of y minus y over x minus x. Well, the slope of PQ is, we'd say, instead of y, we're going to say f of x plus h, right? Minus the other y term, f of x. Now, whatever order you use, you got to use the same order with the x variables. The y minus y, y2 minus y1. Well, this would be x plus h minus x. Now, we've seen something like this, right? We use 2 plus h minus 2, and f of 2 plus h, and so on. So this just simplifies. As you can see, the x's on the denominator cancel out. You just have over h. So I'm going to use that here. We want to make that h as small as possible, so we use this limit. So the slope of the tangent line is given by this limit. The slope of the tangent line is equal to the limit h approaching 0 from either side for the slope formula. Now, this isn't earth-shattering, it's more or less what we've been doing before. We call this a derivative. We'll have a notation, several notations for derivatives. But before we get into notation, I want to talk about an explanation so that you understand it in words. Because I think you could think back to, this is analogous to being in grade 4 or something like this. You learn how to multiply and you memorize things. I hope. Did you guys memorize your times tables more or less? Maybe not consciously, but you did them enough that you have them memorized, right? When I was a kid, we used to actually work on memorizing them. And the other way works too. But you can have them all, you can talk to a grade 3 or 4 kid and they can say 2 times 8 is 16, 3 times 8 is 24, etc. But then you say that you have a brick wall and there's 3 bricks on the left and then going, the other direction, you got 8 bricks. Without counting each brick individually, how many bricks do you have? It's a 3 by 8 grid. I hope they think of 24, or all kinds of situations. You really don't understand it until you start solving problems with it, right? So you've got to be able to verbalize this. And here's 2 things that we're going to have. The definition, which you've got to know, but then the description is actually more useful when you're solving problems. So, the definition is carefully worded. So copy it up. If you have a function of x, y equals f of x. So that could mean x squared plus 5 or whatever. Then the slope of the tangent to the curve f of x at the point, at the general point, x comma f of x is given by here's the new expression. Well, it's not new, because we've seen it. Here's the new notation. F prime of x. And then we have the limit of the slope. You will need to memorize this, but there's not a lot to memorize. You will need to memorize the formula portion of this. And you will need to know that it gives you the slope of the tangent line to the curve. Or at least gives you a formula to find the slope of the tangent line. So, as far as, and I can tell you this, this is regular calculus, there's nothing AP about this. In Math 110 in University of Regina, in my calculus class for you, calculus class for Eddie, because I'm not giving a different test than the regular calculus as far as that's concerned. You will have a question, usually, that will say, apply the definition of the derivative to find the derivative for such and such. That means you're going to use this to do your derivative, because later on you're going to have some shortcuts, and they're really short. But if I say use the definition of the derivative, great. The AP questions, you'll have, they've applied the definition of the derivative, and they'll have something plugged in like this that resembles this limit here. And you'll say, hey, that's the derivative. I know a shortcut to do this rather than do it this long way, too. But more about that when you get to that. You've got to have this memorized. And basically, it's the slope formula, right? And you know how the denominator x plus h minus x, it just simplifies to over h. H is approaching 0. That's the limit portion of it. It's not a lot to memorize if you understand that you're limiting h approaching to 0 for the slope formula. Now, a description of the derivative. This is not a carefully worded definition or anything like this, but I want you to know this, and I'll get you to repeat it with me at the start of some classes sometimes too. We'll see. The derivative is a formula. This is just my description. It's not a formal one from any textbook. The derivative is a formula. That gives the slope of the tangent line to a point on a function. This is what I call a description. It's a formula. Gives you the slope of the tangent line to a point on a function. Why? Because you're going to be solving problems. And it won't say find the derivative. It'll say find the slope, or find the equation of the tangent line, or find the slope of the tangent line to the point 3, 5, or something like this for this function. And you'll say, what I need is a formula that gives me the slope of the tangent line. Hey, that's called the derivative. So it'll be like that. And you're going to come across this throughout the course, right till the last day. You'll be doing these derivatives. Keep this in the back of your mind, okay? Sugar-free. It's good. Product placement. Now, great. Shindalka, how does this work? Any questions? Use the definition of the derivative to find the slope of the tangent line to this function. Now, before you would have said 2 and then 2 plus h for your x values. We're going to apply this x plus h minus f of x plus h minus f of x, the slope formula. We're going to apply that definition. So what I'm saying is we're going to find this derivative. F prime of x is how we read this aloud. It means the derivative. We'll find out there's other notations that we can show derivatives. So I'm finding the derivative. I'm going to move this to the left. For limit h approaching 0. I'm just rewriting the definition. Okay. And I advise you to write it out when you're doing this kind of work, because it'll be ingrained in your head, and it'll be, without making effort to memorize it, you'll memorize it. Okay? If you understand it, you might already have it in your head. So, let's apply this definition to this particular situation. In this particular case, my function f of x is x squared. So what I'm going to do is I'm going to put x plus h into the function, right? So, I'm going to do it one step at a time. So, x plus h plugged into the function minus the function itself, f of x, so that's just x squared, over h, which is approaching 0. You take a quick scan. Nope. It is indeterminate. I would have 0 right now if I tried this out. It's not going to work. Right? Remember, whenever you have a limit, take a quick scan. Can you just do it as is? Nope, because I'd have 0 on the bottom. If I put 0 in here, I'd have x squared minus x squared. 0 over 0 is indeterminate. It means you got to do some more work, see if you can figure out a way to figure this out. So, we got to multiply it out. So x squared plus xh plus xh, when I multiply that out, I'm very careful never to say a word that I disagree. It's a way people use to memorize how to multiply that out. What am I not saying on purpose? How do you guys describe multiplying this up when you were in grade 10 or something like this? Foil, but I know what you mean. I think, do you realize, because foil, then here's what happens though. What if I said multiply this up? And here's why I don't talk about foil. Can you do foil on this? No. But it's the same skill, I just don't call it foil. You distribute, right? I multiply the x with this, I multiply the x. You guys realize that's what really you're doing, foil? Okay. And then you multiply this, and then you okay. Here you distribute 1, 2, 3, x times ABC, h, right? You could do that. And of course, if you had 5, okay, you can extend that idea. That's why I don't say foil. I do sometimes if I know somebody speaks that language, and I'll do that. Anyways, all over the page. By the way, if you're the kind of person who hates a long denominator like this, or a fraction like this, if you want to pull this out, I'm not going to do this, but I'm showing you. Isn't this the exact same? If I didn't have that line there. If it makes you feel better and you want to put 1 over h times that long thing all the time, you may. And you sometimes see that, but I'm not going to. So. It's just a notation thing. Some people like squeezing everything into a neat line on their book and stuff. Anyways, when you do this, and if you've multiplied it out properly, you'll always notice that the only things left behind have h's in them. Like this x squared and this x squared cancel out, right? X squared minus x squared. So I'm going to write this out explicitly without doing any other steps here. I think you could do a few steps in there. So there it is. Everything's got an h here. What can you do now so that you could solve the limit? Yeah, you could distribute the h, the divide by h portion. So you have, and I would not be surprised if you could have skipped this step and just like went to the next step right there, and I trust that you could. Okay, so I'm just saying I'm showing more steps than you might show because I'm trying to instruct. So 2x plus h. Now, once I've gotten rid of the fraction, do you notice I put this in brackets? I sometimes forget this too. That's because the limit applies to the whole expression. When you have a rational expression, it's implied that there's a bracket around there. You know what I'm saying there? That's one whole unit? Okay. So this, there's nothing to do on the 2x. Yes? Yes, I did, man. I don't know why I changed it, just because I'm chatting it up, and thank you so much. Emma saves the day. Why didn't somebody else notice that before? Oh well, they didn't. Ask questions as soon as you notice something's fishy. I sometimes start talking and I'm, yeah. Anyways, I can't believe I didn't notice 3 times in a row. So anyways, we've got 2x. Now, it's the same amount of work as when you use the 2 plus h method, right? However, now you have a, if I had multiple questions on this, this is a formula, we found the derivative, that gives you the slope of the tangent line at any point. So if I was wondering, at 2, what's the, use the definition of the derivative to find the slope of the tangent line. At 2, well, we put that in there, 2 times 2 is 4. But now I could do a bunch of them quickly. At 10, 2 times 10 is 20. At negative 5, negative 10. You follow me? You now have a formula that gives you the slope of the tangent line at any point. Because I didn't write this down every time, but this f prime of x, yeah, it's a quadratic. So the slope is changing all the time, right? On the graph, right? So at 2, it's going to have a slope of 4. And and so on, right? Over here at -3 or something like this, would have a slope of -6. At 0, it would have a slope of 0. Hey, these things make sense, right? Okay. Now, to answer this question, the derivative at 2, because that's what we were asked about, is equal to 2 times 2, it's 4. That is the slope of the tangent, okay? Okay, I could have put as f prime of 2. Yeah.
This would be the method you used for the last question on this assignment?
Nope. You're going to use old school, use chapter 2 methods, I know. We're going to learn shortcuts, and on the test, you'll be tempted to, but I'll say, nope, use chapter 2 methods. Is this really any different than using an A, though? No. Okay. What he's asking about is, all I said is I said, plug in A, oh, okay, my A turned into a circle, but it will come out to be the exact same, except the same question, except you'd have f prime of A is equal to 2A. It's, stick with that method for there, though, okay? Because you're describing a particular number. Now, I could apply this to cubes. I could apply this to the power of 7, x to the 7 minus 3x squared. Do you know why I'm not going to give you those ones? Because you know how long it takes. Squares, cubes are the limit of what I'm going to give you as far as exponents. Because it gets stupid after a while, right? You're just going to make algebraic mistakes. Now, try this. Use the definition of the derivative to find x prime, or find f prime of x if the function is 2x squared minus x cubed. This is what I'm saying. X cubed is kind of the max. And so on. And I've done it. It takes me pretty well the full page to do it. Now, you would find a derivative, a, and then you're going to use that to find f prime of -4. What does that represent? It's the slope of the tangent line. X equals 4, -4. And then you got something else to try out afterwards too. It will take you a full page. I'll leave that with you to do. I'll pause this recording.